Can we print its metadata? Because we are trying to create a scalar tensor, and for some reason it's just not printing out the tensor. So can I create its metadata? Yeah, this could be one way. Let's just try to create its metadata. So tensor metadata s, and let's see if this one works. Metadata. Okay, so we are getting shape, abnormal shape, and something is wrong here. So something is wrong here. We are not passing the correct shape. So shape 01. Size of integer, so storing only one item. So okay, so I think something is wrong here. It should be like this, I guess. Still not getting the correct shape. What is M shape, by the way? It's coming from what is M shape? Fill zeros and tensor metadata s. Let's just, can I exit this tmux because I'm not able to see the syntax highlighting. So let's just, I need to focus on this, right? So here it is. So we have created mean expanded columns, and we're not interested in this one for now. What we are interested in is why is it giving me the incorrect shape? Oh yeah, so I think this should be 2. Yeah, we're getting the correct shape now. And 1 cross 1, and let's just try to print its metadata now. I think I can open a tmux now. Tensor dot p and yeah, so let's just get this tensor now, and tensor get 2d s. Yes, we are able to get the tensor. So you see there's only one value, 0.61, and now it basically worked. So we have a tensor of shape 1 cross 1, and this is super nice. We can use this for a loss tensor like this, and now we just want to create the shape, sum all the elements. Like this, shape expanded, and this will work now. Now we have tested this is working, and well, now let's just calculate tensor. Loss would be tensor create new, and need to specify the shape. So here we can create this tensor loss is going to be tensor, create new a 2 dimensions and s shape, right? And now let's just loop through expanded and take one value, sum every value. So int loss is going to I can say sum is going to be 0 for z equals to expanded shape 0. No, sorry, it's starting from 0 less than this, and for C++, and now we need to just sum it, right? Sum plus equals expanded data. Yeah, so expanded data are times this thing. Oops, what just happened? Let's see, like so. And now we are going to assign this loss tensor equals sum. Let's say loss data equals sum, or what? And now let's just try to print this tensor get data get 2D. Let's see if this works. Segmentation fault. Should we assign loss? We cannot assign loss sum. We can assign loss data as sum. Loss data equals sum. Like so. Seg fault. Have we calculated sum correctly at the first place? Let's just figure out 0. Expanded data. So expanded data and fill ones main, expand columns. There is some data. Oh my goodness. Oh man. Incompatible types, float, pointer. Really? Did it print sum at the first place? Let's see if we are getting the sum. We are getting the sum now, so I think let's just pass its reference. Alright, so 343. Yeah, that's correct. So now it's working. Seems like it's working. So we've created a loss tensor. And this is actually the entry point from where we'll be starting our backpropagation. So yeah, loss created. Fine. So now, if you want to create the derivative of this loss, how actually can we? Derivative of this loss is going to be 1 because we're taking the derivative with its own self. Um, to the loss, its gradient. Mm, yeah. So we have calculated the loss, summing all the values which were coming from expanded columns, and now what we are doing here is we are trying to calculate the backward tensors gradient as well. So for loss, we have only one scalar value, and this is the scalar value that we have, right? This is the scalar value that we have, sum right here, and then I want to have gradient. This is going to be dl over l. This is going to be 1, and yeah, this is 1 for now. And now the gradient is 1, which is great, and now I want to find out the gradient of the expanded columns as well, which is going to be like for example, let's say we have something like this, dl l by l, which is going to be 1, dl by, let's say, y equals to f of x. That is summation I equals 0 to n, all the values of this matrix, and then dl by dy is going to be tensor dl over dy at ith index, let's call it x at I index, and this is going to be 1. So we will have expanded columns grad equals tensor of ones, right? So let's just do this now. We simply go ahead and fill ones. So it's like expanded grad So if expanded grad, if not, let's just grad f print f, gradient not found, and the function is tensor columns, right? And return 1. Otherwise, just do something that calculates the gradient. So expanded grad equals tensor fill once a, and what 2 for n dimension, and then we have expanded shape. And now let's just try to print this. Tensor get 2D, this time it's for expanded grad. Let's see if this works. TensorFill wants too many arguments. Okay, let's just see what does it take. So it takes only x, just returns nothing. Okay, fine. So it will be something like this. It just takes x and yeah, expanded grad. This is digression f print. Okay, let's have a look again. So TensorFill once, expanded gradients will be 1, and tensor get 2D. This should work now. Perfect. Expand columns backward. Expand columns backward. So I think this chain rule is working fine. So how this is working fine? So we are successfully able to do this thing. So first of all, what we did actually is, let's have a recap. So we just calculated loss applying sum function on this output tensor. So we have applied the sum function, and this is actually our sum function, and we have populated this loss data as sum, because it's loss data as sum, and its gradient is going to be like 1, right? So its gradient is going to be 1 with its own self. Then we backpropagated one more step, and we had the tensor called tensor expand columns. And for expand columns, I have written some mathematical expression over here. So for example, f of x is equals to y, and dl over dy is going to be the the gradient will flow backward, right? The gradient will flow backward as it is for each and every item in the tensor, because previously it was for only one item, one single scalar value, and now this scalar value will be propagating towards all the items in the tensor, and this is what we got. So we applied a check over here, and then we just fill the ones, right? So we have calculated till here, and this out has been stored now. And now let's just try to calculate tensor backward. So one thing with tensor backward is it receives and transforms. So for tensor backward, especially because it's a very last tensor, I think I have to create one more parameter in the function which receives the previous value, because for every other operation, because since it's a very second last operation right before the loss, so we have to have some way of getting this gradient flown down to the gradient of tensor expanded columns. So that's why we are passing one more parameter which takes the loss of the previous and then just transform. For the later ones, we will be using only one tensor, or if we can do this like for all the methods, that would be even great, to receive the previous gradient and then to transition that downwards to the children or parents. Like, I'm always confused with the children and parents. I think these are parents, not children's, because they created the tensor. So tensor itself is children, and the operations, the tensors that are involved in creation are the parents, right? So okay, so now what is going on here? Tensor expand columns, what it takes. Let's see what this function is doing. Well, it doesn't do anything. It just, transforms or flow down the gradient to equally each and every item of the tensor. So this is wrong. This is wrong. This is actually for mean calculation. This is not for this particular one. So let me just comment this for now for a second, and let's just create a method. Void tensor expand columns backward. And what does this take? It just fills one, nothing else. So instead of it just filling once, I just wanna grab the value of the lost. Let's just let's just take loss, right? And okay, so tensor square backward. This is commented out. Tensor expand columns backwards. So void tensor. This receives tensor. Let's say tensor out. Let's call this loss out, right? And so we need to make it generic because we've used this at the other places as well. So tensor expand columns, it just receives out, and also it just receives loss and tensor x. Let's call this out and this one loss. So out is like coming from actual forward pass, which the gradient of that out will be populating using this loss tensor. So now out is the forward pass output. We'll be updating out grad here, and loss is the previous tensor, and we'll fix this later whether we want to have this loss or not. Let's just do this for now. So let's just find if not loss, let's print f loss is empty, loss is null, return if not loss grad is null. If not loss grad, so there has to be loss grad, right? There has to be loss grad. So so we need to look at whether this loss is single scalar value or the tensor itself. So we can do it in lots of different ways, but right now we know that it's only 1x1 matrix. So let's do it for now, but we'll fix this later because we've used in tensor expand columns operations in lots of different places. So let's say for val equals loss data, and equals lost data, right? And what it is like, let's just see what it is. Val so this is expanded, which is our out, and this is our lost tensor. Yeah. And let's print this. Okay, so I think we're not printing anything. So we are printing this. Yeah, lost data incompatible, correct. I don't know, what am I doing? Okay, so now we have another issue here. Let's just resolve that too. So tensor expand columns backward. Need to set this here too. Rows backward. Uh, 726. What's wrong here? Expand rows backward. Yeah, that's the one I want to use. Let's remove this. Okay, so we are receiving some value over here, and this is yeah, so this is actually the value. So we are dereferencing it over here, and we have val 245, right? So it looks like we have extracted the value, and now let's just take this value and like smoothly transition, or shift this value to all the values of all the elements of expanded columns output. So let's just do it. So for rows equals out shape 0, and this is going to be Let's just copy this. Perfect. Okay, so rows and columns, and now for int r equals 0, r is less than rows. Or can we just copy this? I think we can. Or we can use tensor fill once, which is doing the exact same thing. Fill once or fill value? I think we need to change this method fill once, because it could be any value, any float value. So x, yeah. So this should be float val, right? And like fill this with like what? Val. Or can we create another function? Okay, so I don't think what should I do. So let's just not mess with this, and let's just create another function which just fills the values and fill and update simultaneously. So I think we have some such method. Let's just check fill values. Tensor fill val, so it takes integer value. Tensor fill ones, tensor fill zeros, fill width, let's just say float v, and this should be v here. V, and let's just add its prototype. Fill width. Okay, so fill width, and yeah. Yeah, and tensor okay, so I think we can take the pointer of this thing. That would be fine. It's wide tensor fill width, and this is actually a pointer, right? Or let's pass this address, right? And tensor fill width, if expanded, if let's say if not out, f print f standard error, out is null, and this should exit, return and tensor with out and what? Well, correct. Okay. Tensor okay, fine. So now we have here expected error before this, so tensor h. Oh, oh wow. Wide tensor expand columns backward, and this is fill with, and this is incorrect. Val incompatible type. Okay, so tensor C has issue. So already a pointer. Incompatible for argument 2 of tensor. Tensor filled with out. It's a float pointer. Yeah, this should be a float pointer. Expected float, but argument is of the type float pointer. Okay. Okay, and this should be a pointer. X data V should be address of V. No. Alright, so I don't know like what's going on here. I think this is working fine. So let me just go ahead and do one more thing. think I need to just remove this pointer. This should not be a pointer. We can make changes in our expand columns backward function. So this is not a pointer. Expand calls backward. Okay, so here you can make the changes, right, and can we simply do this? And if this works, I would want to check as well. So tensor, we'll get 2D and out grid. Well, I should not populate out data. One more thing I wanted to fix here. So tensor fill with, it should, if not x or not x red f print f. Otherwise populate x grid data. Okay, this is what we need, right? And I think I have applied double checks over here, which is unnecessary. And okay, so loss if not out. Okay, and if not out, and it checks in TensorFlow with as well. Is it a good practice to apply double checks? I don't know, because I think yes. Now the question is, what value are we passing this? Grid data. Voila! So we have successfully calculated the gradient for this function, expand columns, and next time we will be applying the same function, and which will calculate the values recursively. And this was it for this video. I think the video has gone already pretty long, and I'll see you in the next one. Take care.